Hello people, this is the first video where we're gonna start talking about morph targets or blend shapes. So morph targets is the word that is being used in Unreal, in 3ds Max if I remember correctly. In Maya it's blend shapes. It's the same exact thing. So I'm gonna try to use as much as possible the Unreal version of it, this one, but if I every now and then mention blend shapes, just that's just the force of habit. Is the same thing. So before jumping on that, today in this video, as usual, when I start talking about new topic, I'm just gonna make some observation, and what am I going to go through is a bit of naming convention and stuff that, if you guys are familiar already with morph targets and blend shape, this information you already know. But I'm gonna try to take this, a step back and try to introduce the concept. So in order to do that, I want to start talking about every time I use the word transformation and deformation. Deformation, transformation. Because before we jump into morph targets and blend shapes, this is something I feel like it's necessary. So usually an object, a polymesh or any other object that you can manipulate in any DCC application has a pivot point and has a transform. And that transform represents the position in space, can either be global or world, world or local. We saw that in the previous classes. When I translate an object from one position to another, I'm going to use the word transform. I'm transforming the object in space. When I'm deforming the object, visually it might actually look the same. But so I am deforming an object. So if you look at this square, it might visually be the same, meaning that I am moving the shape of the object from one position to another. So it might look the same, but what's happening is actually different. Now, why I'm saying this, the reason why I'm saying this is just morph targets is a type of deformation, and is the same thing that is happening on the skin cluster. So skin clusters, which is what we saw every time we attach or bind the geometry to a skeleton, to a series of bones or joints. Skin cluster and blend shapes, or morph target, are deformers. They do not actually transform the mesh, they deform it. So let's have a look in Maya what that means. Again, I apologize for people that are familiar with this concept, but when I need to start introducing this kind of stuff, especially for blend shapes. So in Maya, I have an object, and the object can be transformed. This pivot has associated translation, rotation, and scale values, represented here as Euler coordinates. And what I'm doing here, I'm moving the entire object. So I'm moving its space I'm transforming the local space of this object relative to the world space in this case. If I were to group this and move the group above, I'm moving the parent space of this object here. So the parent space, so the local space of this object stays at 0, and the parent, it's moving relative to the world. So in the end, is if you travel through the whole hierarchy, you're always moving relative to the world at some point, but the local values are expressed in local space in Maya, and you can see that in control rate. We saw the same transfer can be represented in world space, local space, parent space. So with this said, you can see me. Let me take the geometry out and get rid of this group. With this said, you can see that what I mean by visually, I'm taking the sphere from this position to this position, and right now I'm performing a transformation. Okay. But if I were to select the vertices of this object and transform each vertex into a new position, visually it looks the same. But in this case, what I'm doing, I'm deforming the object. I'm not transforming it. And you can see that because the pivot of the object stays at the origin. Okay? So I'm not moving the object, I'm moving the shape of the object. And this is critical. The space concept is critical when it comes to morph targets. Before jumping on morph targets though, let's apply what we already did many times. So we have, let me visualize the joints. I just need one joint actually. When I apply a skin cluster deformer, again, this is just Maya, but so I'm not going to go through how to do that. This is just to explain. Let me increase just the radius a bit, just so we can visually see. This does nothing, it's just a visualization. If I select this object now, if I select this joint now and move it, you can see that the sphere is moving with it, but if I select the sphere pivot is still there. I'm not transforming the sphere, I'm deforming it. So again, in skin clusters, it's, oh, not that. Skin cluster is a type of deformer, and the same is the blend shape. So if I were to quickly create a blend shape, very quickly, unlock this stuff, and just change the shape a little bit and apply this as a blend shape. Actually, let me do a different thing. Let me take all these vertices of the target, of the duplicate, move them here, apply them as a blend shape. What I can do now is I can deform the mesh into the new position by this slider. This concept that I'm going through are true to every DCC application, including Unreal. So I'm using Maya, but this thing is happening. You can do the same exact thing in Blender, 3ds Max, XSI, whatever you can think of. Doesn't really matter. And Unreal, of course. So from here, I'm simply saying that the new target of the blend shape node that is applied into this mesh, the new target is in this new position, but I'm not moving the object, I'm moving the shape of the object. So what you get as a result is that you have a geometry that when you trigger the blend shape, it goes into this new position. But the object per se has not moved, the pivot is still there. And because there is a chain of deformation here, in Maya you read this chain of deformation in this order. The lowest happens before the one that is on top. So first the blend shape happens and then the skin cluster happen. What this allows us to do is to chain deformers together, and basically you can move the joint and apply the blend shape, or same, apply the blend shape and then move the joint. Okay, so this order of deformation is something we're gonna touch constantly upon, because the way this works, as you can see, we have a skin cluster, and before that we have a blend shape. So the blend shape is computed before the skin cluster. So once we jump properly inside Unreal Engine, we will have to know how to connect these two things together from a DCC application we're coming from. A blend shape that happens before the skin cluster is usually called front of chain. If I use the Maya terminology, it means that is a blend shape that happens before the skin cluster, is in front of the chain. So both of these deformers are happening one after the other, and in order to make the blend shape plus skin cluster work, you need to have this kind of order. First needs to be a blend shape and then a skin cluster. Now this configuration here is very standard. This is pretty much the 101 of rigging. This is how rigging has been working for like 20 years. And Unreal Engine by default ingests this kind of structure, meaning that first wants to compute the blend shapes or the morph targets, and then he wants to compute the skin cluster deformer. Okay, so the blend shape, the blend shape, when is applied like that, so first the blend shape and then the skin cluster, I'm going to say that the blend shape works in local space. But the truth is that you can change this deformation the way you want it. It's just, it depends if you want to make it work in a real-time engine. So 99% of the time, this is what you want to do. But Maya, this is like Maya or, you know, anything really, allows you to swap the order of deformation. So for example, if I do the blend shape again, but this time I'm telling the system, hello, where's my UI? For some reason it's not taking the UIs here. Okay, so if I'm saying the UI to apply this blend shape afterwards, let me get rid of that again. To apply the blend shape post deformation, you can see that now first is the skin cluster and then the blend shape. When that happens, when there is the skin cluster first and then the blend shape, I'm gonna start referring at this blend shape here to be in tangent space. Now, all of this for now are just words. For people that are not familiar with them, for now are just words, and that's absolutely fine. Just so you know that the order of deformation to make the blend shape mechanism works in Unreal is important, and 99% of the time we're going to be talking about this. Okay, so to achieve something like that, there are reasons why you may want to use this, but it's very, very advanced. For now, there is absolutely no reason to touch upon that. So most of the time we're going to deal with blend shape front of chain, so the blend shape happened first in local space. Afterwards we will have a skin cluster. So blend shapes, what are those? Why am I moving things around? Let me get rid of all this stuff and let's start with example number 1. So a blend shape, it's both actually blend shapes and skin cluster are both linear deformers. What does that mean? It means that the interpolation that they perform, so the algorithm that is moving vertices around, uses a linear interpolation because it is extremely fast. In the case of the blend shape or a morph target, you can specify targets with different shapes, apply them to an original shape, and have them basically being triggered using blend shape weights. But what all these words mean is that I can select, so we have 3 objects here. The yellow one is my main object and the blue ones are my targets that I modeled. So the way I created this is as I simply duplicate the geometry, selected, and move it by a precise amount of units to make this example. Okay, so now in Maya I'm going to apply this blend shape here, and now you can see that I have both of these targets as weights or targets inside my blend shape node. What this allows me to do is to trigger the blend shape, and you can see the value from 0 to 1 moving precisely until a number weight 1, it reaches exactly this position. Okay, if I put this back to 0, it goes back. If I put this to 1, you can see that they're reaching exactly this position. So you can imagine that by animating this value, you can achieve really interesting results that you cannot achieve via simple skin cluster or you know, bones manipulation. So being this, what does it mean that all of these are linear? We're going to see that in a minute, but before that, I can combine morph targets together. Imagine that there is a list of 10 targets here. I can animate all of them with a certain value. Now here I have used this target here and I put it to number 1, and let's see what happens when I use this target here at 1. You can see that the local transformation of this vertex is be taken into account. So the fact that this vertex only moved that direction means that this vertex moved upwards, but this vertex also moved outwards. Okay, so you can see that by combining blend shapes together, you can achieve a brand new shape. Okay, and this is the power behind, for example, face rigs. Certain technologies around face rig can revolve entirely around blend shapes. Usually what you find is a proper hybrid between blend shapes and joints, and there is a reason for that, and the reason sits behind the word linear. So this is all looks great, but blend shapes being linear can have some problems. If you only use blend shape, front of chain blend shapes, you may encounter certain problems. What are those? Example number 2. So this yellow, it's my main geometry, and this blue is my target. Okay, so this blue has been simply made by selecting all these vertices, move them like that, and move them here. Right? So what do you expect that it could happen if I apply this blend shape now? So these vertices will go, if I put this to 1, you can see that they're on top of one another now, right? So if I put this back to 0, 0.1, 0, you can see it's moving, 0.95 is moving toward that direction. But you can start, if I instead blend, and instead of the typing value, blend between one position to another, let's have a look at what's happening. Can you see that the object looks like it's shrinking, 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 and then it pops back? That is the limitation of a linear interpolation. Okay, because linear interpolation only means that if I have this object and this object, imagine that these two objects are vertices, so each one of this. Linear interpolation means that the way the deformer works when I trigger it is that this vertex here is going to find the closest path to reach this position. So the reason why I'm making this example is because, you know, if you're not familiar with this kind of stuff, you may assume that this object, to reach this position, it goes in a really nice and clean rotation like that. Right now I'm just simply rotating the object, right? So it looks really nice and clean. It creates a nice arc around here. Let's have a look. Let's create a circle. So if I take this object and rotate, you can see how it stays on the circle because I'm transforming the object around Euler coordinates. But if I am only deforming it through a blend shape to reach this position to this position, you can see that the thing is that it does not stay on the circle because all these vertices are reaching the sibling vertex, the vertex that corresponds to themselves, into a linear manner, right? So you have to imagine a lot of lines that are going from here to here. Let's try that. Let's create a line. Let's try to see this one to here. right? So imagine that there is that line over there. It's not precise, but it's just to have an idea. So this vertex stays on that line and linearly reaches that line. You see? So why am I saying all of this? And I know that you guys know morph targets. Yes, it's a smile, it's an open mouth, it's a blink. Before jumping onto all of that, it's good to know what are the limitations and why the setup that you want at the very end is a setup that is a hybrid between linear blend shapes and joints. Because joints, if you create a joint, you can skin it, but the joint then you can rotate. So you can help the deformation through a transformation that is happening on the joint, not on the geometry, plus the blend shape. So that's how you get the best of both worlds. You get a nice interpolation, but also you get all the power that a blend shape can give, you know, by sculpting, for example, a very nice smile, something that a joint can never, because the joint is a subset of vertices. It's a discretization of the amount of vertices are on the geometry. So if you have 100 vertices on a face, usually you have, I don't know, 30 joints. So you cannot represent the complexity of the deformation of the face if you have a subset of transfer to move around. So the blend shape, that's where it comes to play, because with the blend shape you're defining the shape by using the entirety of the vertices that are composing the face. We're going to see that, but this video is just an introduction to make clear certain things. I hope you found this thing interesting, and soon we're going to move into Unreal, but not in this video. Bye bye.